All right, cool, awesome. Welcome to sort of LUCMA, no servers. How serverless architectures are going to change the world of at least software development. Let's just start small, right? Let's start small. A couple years ago, I was speaking at a conference, YOW, or at least another major conference here in Australia. And in that talk, I sort of posited this, right? The talk was about Docker, and my point was soon deploying applications is going to be as outdated as manual memory management for exactly the same reason. Yep. Because we can't be bothered with that shit. Yep. I've got more important things to do. And I'm sure someone from AWS was in the audience, because it wasn't 6 months later when they released Lambda. Yep. Of course, these things are causally related. And Lambda was a massive, massive change in the way that we sort of use and build software. It's a tremendously powerful thing. And basically what Lambdas are, and now Azure has functions, and Google, I think they're called Google Functions, and IBM has something, which just shows you how powerful this is, right? If we're talking sort of in a year and a half, all of the major cloud providers are sort of supporting this now. But what a Lambda is a really interesting thing, is I upload a piece of code to AWS, and then say to AWS, please run this piece of code if this particular event happens. Yep. It's that simple. And that's sort of where most of its power lie. So I want you to sort of run through an example of what's now possible with this type of technology. And we're going to do this. I'm going to go and try and to show you how easy it is to live code an application. Now, the only thing I could find to sacrifice to the sort of demo gods was a Windows laptop and an old mouse. So please bear with me. But we're going to see how far we get. But let's just give you an introduction, sort of the application that we're going to be building together. And it's a good old-fashioned sort of like forum. Yeah, was anyone alive in the 90s? So that we did forums back then. Sort of forums, comments. It's a pretty basic thing. But this is how we're going to start out. Right? I've created 2 DynamoDB tables, and DynamoDB tables is sort of the NoSQL single table store that AWS had. It's extremely powerful. Yeah, so we have 2 DynamoDB tables. And what we're going to be building is 3 sort of lambdas that are in front of those DynamoDB tables. We're going to read and write to them. And in front of that, over here, is sort of an API gateway. Yep. So let's see what that sort of looks like. That's not what I was hoping for. I want you to mirror the displays. All right. Yep. So, where the hell is DynamoDB? Of course, the interwebs was working fine in the break. There must be some boring talks on right now. There we go. All right, like I said, 2 DynamoDB tables, right? Nothing fancy going on. And what we have configured is something called API Gateway. Now, API Gateway is the gateway for APIs, believe it or not. You guys are a tough crowd. Is it like 6 already? So yeah, it's an API gateway, and basically what we're doing is we're defining sort of REST-ish APIs. And so what we've been doing is we've defined a resource called threads, and then we can sort of define our methods on there. So this is our threads with the get. And in here, we sort of specify that we could call a lambda function. I don't have any lambda function. That's unfortunate. Let's go create one. So we go to lambda, get started, go away, skip, left for next. This is great. Smaller screens, your entire thing's different. So get threads. Let's just call it get threads. We're doing the node. And here we are. Now remember when I said that lambda is this. You see less on that screen than I see on this screen. This is fun. So as I said, lambdas is this piece of code that you upload. Yeah, and then you tell AWS sort of run this piece of code when this event happens. Yeah, and this is sort of that event that we see over here. Context has some context, and the callback is when we're done. Yeah. That's sort of how this works. So let's go and sort of figure this out, right? So what we're going to do is we're going to do sort of two things here, right? If we've specified a thread ID, we're just going to go and do a query on the DynamoDB table. So if we have a thread ID, we're just going to do table name is demo threads. I'm fairly certain. And the key is thread ID, event thread ID. And braces. Now we go require AWS. And a DynamoDB table. DB. So now we've sort of created a DynamoDB connection, and now we can go get, and then so if we have data coming back, we'll just do callback to error data.item. And if else, we'll just call back the error. Yeah, you can still see that. All right. So then what we'll do is we'll tell them sort of what function to call in there. We're going to choose an existing role. We're going to do this. Here we can say how much memory it needs and sort of timeouts. And this is everything we need. Congratulations, your Lambda functions is now sort of created. And here's the interesting thing. Configure a test event. Thread ID is, and I should go look this up. Nope. What I put in the DynamoDB tables. Nope. DynamoDB. threads, items, thread idea. Almost. Right, so drum rolls. Drum rolls. There you go, thanks. There we go. Yes. Yep. So this is the output. Right? So this is everything we needed to do, and if we now sort of create this lambda that does a request to our DynamoDB table and returns that result. That was what? A couple minutes. And if we now hook it up to this one, this one, get threads, we can now test this here. $500, of course. Gee. Demo gods don't like Windows laptops, apparently. Yes. Permissions are always good fun. I want to do that. I want to do that. I want to do that. Get rid of that one. Nope, get rid of it. See? Something doesn't work. Either reboot or delete it and do it again. We've now created a microservice in 10 minutes. That wasn't spectacular. There you go. Damn, you're tough. So here's the thing where that sort of gets fun, right? This is not just created the microservice, because creating microservices in 10 minutes is easy, right? Everyone can do that. But this is a production-ready microservice running in production, right? Without me configuring servers, runtimes, platforms, CI/CD pipelines, none of that stuff, right? Now, this particular microservice will do 1 request per second, which is pretty good, right? 1 request per second. Yeah. But the problem you have when you're scaling applications is doing that order of magnitude scaling. So what you see, if you sort of go up an order of magnitude from 1 request per second to 10 requests per second, right? This is what makes it hard on your infrastructure and on your code, and often requires to change the way we think about infrastructure and the way we think about code, right? So let's see what we need to do to get this particular microservice to do 10 requests per second. Let me see. There we go. Threads overview. I can't get everything in here. Capacity. There we go. 10 requests a second. Yep. With bursts up to 3,000 requests per 5 minutes. Still not impressed. Damn. All right, 100. Let's go. Oh, the version capacity is updating. So yeah, right, we're now doing 10 requests a second. If you want to do 100 requests a second, What do we need to do 100 requests a second? Update that to 100. Oh, and pay the $2.32 a month. Right? It's not important. It's pretty important. If we want to go sort of beyond 100 to 200, we have to email Amazon to please ask us to run more than 100 lambdas at the same time. Because that's what Amazon's doing. They're sort of spawning, and they're spawning up these lambdas all over the place. Where I don't know where that is, but somewhere in Sydney, somewhere around here. Or I don't know. I don't know what availability zone they're in. I don't know what server they're running. Amazon takes care of all of that. Yeah. If we want to run 1,000 requests a second, 1,000 requests a second, we sort of have to go in here and go. If you want to move beyond 1,000 requests a second, you sort of have to up this number. Yeah? And that's what makes it insanely powerful. Where is my... Yep. Stop mirroring these things. Yeah, that's what makes lambda so powerful. So we'll have 2 more, right? We're having 2 more. We'll do one for the get threads and one for the get posts, and sort of 1 lambda for new posts that are coming in, right? We're doing a post from API gateway to here, and we'll just store that in the post database. Yeah. All lambdas that are looking very, very similar to the one I've just written. Yeah, trivial. But here's gets interesting. Right? What API Gateway can do is it can sort of have custom authorizers. So I can protect these resources that I have, and every time a request comes in, Amazon is going to run my little lambda again to check whether I have access to that. Takes care of all the caching, takes care of all of the provisioning. And again, we don't know. We don't care where these things run, what they do, how it's going. Now this is powerful. This is extremely powerful, but here's where it's getting even better. Because they're not just, the events aren't just sort of API gateway related ones. Every infrastructure component in AWS is able to generate events when things happen. So we can write a lambda that gets called every time something changes in this DynamoDB table. So when a post is added, we write to this table, and we can now run a function that update the last posts in a thread over here. And we can chain all of these events together. So an event happened on the API gateway, this one is evolved. This goes to the DynamoDB table, this one's called. That goes here, other stuff happens. Yeah. Extremely powerful, extremely small pieces of code. Yeah. And then we can have our sort of little single-page JavaScript app, and we can host that on S3 and CloudFront. We now have a fully CDN front-end application connecting to a sort of web service-y type backend without provisioning any servers, without having to spin up EC2 instances or even Beanstalk. There's no scaling groups. There's no nothing. Right? All of your logging is sort of put into CloudWatch for you to sort of look at. Yeah. Massively powerful. So what are some of the consequences of these things? What sort of, if we start using this to the sort of the full advantage, what's sort of happening, right? And the one thing is, so that we get to the point where it's microservices all the way down. Yeah. Not that many Terry Pratchett fans in the audience? No? Go read Terry Pratchett. Maybe even more important than the rest I'm going to say. So what we see is we break down those sort of microservices and we break them down into smaller ones. If you looked at that new post, the new post microservice was divided into two pieces of code. Right? The one that accepted the new post and the one that also updated the threads. So you now sort of get these microservices into even smaller components and smaller functions. The stuff you see very, very quickly is sort of that CQRS or that event sourcing. Makes it very, very easy to do. You almost get them for free. But most importantly, everything in your application is going to be event-driven, which is extremely powerful as we'll sort of go along. But before we go on, I want you to sort of point out some of the dragons, like the here be dragons. Because distributed computing is hard. Yep. Distributed computing is very, very hard. And that's for two reasons. The most important one is that you will never, ever have a guarantee of something happening once. Yep. The only guarantees you have that something happens at most once, or at least once. Yep. And that's sort of one of the major problems in doing sort of these massively distributed systems. You always have to think about what happens if this doesn't happen. So you can either pick, I want this to happen at most once, and if something goes wrong, then that's it, it's over. Or I need to be able to deal with it happening multiple times. So you have to think really hard about your failure modes. What happens if things go wrong, right? Networks are unreliable. That's just the way it is. And the other thing is sort of eventual consistency. If we do this event-driven thing, a lot of this is going to be eventually consistent. There might be milliseconds, tens of milliseconds, minutes, or even hours before something actually happens. You have to be able to deal with that if you're doing this style of programming. And if you thought distributed computing was hard, distributed debugging is even harder. Yep. Basically, every debugging session turns into a murder mystery, where sort of update last post did it with a timeout in the query. Because we're building these chains, if something along this chain, something goes wrong. Right? So it's really, really hard to sort of get that debugging going. Certainly if you're having these individual functions, their individual logging correlating sort of what happens. Certainly in a production system, it's going to be tough. I love this sort of quote, right? There's no cloud. It's just someone else's computer. So we're talking about serverless, but it turns out you still need to know quite a bit on how these lambdas work in practice to sort of get the most out of them. And this is one of my favorite quotes on sort of that computing thing. Like a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. If you start using all of these services, if one of them breaks, you have to figure out what to do. Yep. More importantly, tools do not support scaling. There are some tools out there that help you sort of deploy a few of these lambdas and a few of these other resources. There's nothing out there that will sort of scale this up to tens, let alone hundreds of these functions. Yep. Yet. I actually quit my job last week to go start a startup. in this sort of space, like tooling on how do we sort of scale tooling to the tens and the hundreds of these sort of components that we're building. But more importantly, there is an insane amount of treasure to be had in this style of architecture. Yep. Really cool quote. Our architecture does not include servers for the same reason it doesn't include electricity. It's not my problem anymore. It's not my problem. And if you compare costs, right, two sort of M3 large instances with a load balancer in front of it, sets you back around sort of almost $1,700. 1 million typical API gateway and Lambda requests, about $7, which is insane. Right? You can do tens of hundreds of millions of requests. But the most important thing, not worrying about servers, priceless. And that's sort of what so it's powerful, it's useful, it's cheap, right? Here's something and very, very powerful. The code fits in your head, right? It fits in my head sideways. That's how small your typical code is. Now here's an interesting question. Would you write a unit test for this? Yes? Yeah. The reason you're not a yes is because you've been indoctrinated by TDD for the past 10 or 20 years. There's no point to writing a unit test. There's one if statement, and there's one remote call that can go wrong. There's 4 paths through this code. I can see them, I can reason about them. I want to test it, and I'll test it manually, either in the console or on the command line really quick. I'll test it, but if I get the results I want, that's it. Why would I go to the trouble of writing a unit test for it? Doesn't make any sense. Not anymore. And that's sort of where a lot of those changes are going to come from, right? No more unit tests. One of those other amazing principles, right? Don't repeat yourself. Dry. Very important. Not anymore. Just go and copy all of the stuff. It's self-contained. And here's why. One of the most important things to come out of this is what I sort of call immutable services. Yeah. Immutable services or done services. This code that you're seeing here is done. It is never going to change. Because that's why would you write unit tests? So you can change your code later. I'll never want to change this code. I have my inputs. I have one input. I go to the database and I return whatever's in the database. I will never want to change this. Either I need the entire thing, in which case I have everything, or I don't need the entire thing, and I'll chuck it away. Massively, massively different way of thinking about writing software in these sort of circumstances. So a lot of those sort of quality principles that we've been sort of revering for the past 20 years are sort of changing. And for the record, I was a massive TDD fanboy. Right? It's not like I've never liked this thing and I'm now an excuse. Massive TDD fanboy, except I haven't written a unit test in years. So immutable services, done services. The functions that we write will never ever change, hardly ever change. I'll get back to them afterwards, because I'm sure there's some good discussion going on afterwards. And this is absolute magic, right? This is My Little Pony magic. So let's go talk and sort of go through some of those features, because what happens if we sort of add that little applications of ours, right? So remember, this is sort of the quick and dirty application that we wrote. If we want to sort of email all of the people that are watching a thread, I've got no clue why you would do that. But every forum has this sort of checkbox at the bottom, sort of email me when someone posts in this thread. Yeah. So if we want to build this, how about on this update, we push that post to an SNS topic. We push that post to an SNS topic, and then we have another Lambda listen to that SNS topic. It reads from this database of idiots that want to be emailed when someone posts something. And so when they find something, they're going to talk to SES to send that email. What we're doing is we are adding code when we're adding features. Yeah? See how we haven't changed any of this stuff over here. Like the new post is still the same posts. Yeah? So what happens if we want to do moderation? Right? Because there's all these people that spam on the interwebs, and we want to add some moderation to our thing. So what we're going to be doing is we're sort of adding a moderation table, right? Where we put all of our code, all of our posts that need to be moderated. Yep. And then we're going to add a lambda where sort of moderators can sort of come in and approve things. And if we do, we're going to add them to the post table. And here's the magic. Everything else still works. There's no change in any of the other stuff, because they only get called when we add a post. That something else is now adding that post doesn't matter. So this entire flow hasn't changed. We're still emailing these people that want to be emailed. We're still adding and updating our threads. How about if we want to search posts? We want to search posts. So how do we do that? Well, we just create a new lambda that listens to that same SNS topic when a new post arrives, and we'll just chuck it into Cloud Search. We'll chuck it into Cloud Search, and we'll just add another service over here that just talks to Cloud Search. The only time when you're adding feature, the only thing you do is add code. Right? You hardly ever change code. And that's so extremely powerful, and why I'm so extremely excited about sort of this whole way of sort of event-driven, function-based architecture. That's serverless architectures. Serverless is a terrible name, by the way. Because we're defining something by what it's not, right? That's worked really well for sort of NoSQL. It's worked really well for NoEstimates. And I'm sure it's going to work really well for serverless. Yeah, so the name's terrible. But this style of architecture is an entirely new way of thinking about, and finally doing those things properly that we were talking about. I was having a chat with Koogh earlier today, and he made this interesting remark in that the financial incentives are now in place to do the right thing. And what we mean by that is that we now want to separate out our different functions. Because we build things separately in different modules and in different subsystems. Then we packaged up the entire thing and put them on one big VM because that was cheaper. For the first time in history, we now have the financial incentives to split things up further and further. Because this Lambda might need a lot of memory, but this one doesn't. So we want them to be in separate ones. Yeah. So the first time in history, the incentives to do the right thing are in place. Yeah. And that's not just My Little Pony magic. Right. We are talking sort of My Little Pony and Rainbow magic. Thank you very much. Any questions? People that violently disagree. Yep, you.
Look, I don't know anything about AWS.
Mm-hmm.
That's not a concept. I'm from an Azure background.
Yep.
Have you got experience, with Azure?
Nope, I have. So the question was if I have any experience with Azure.
I'm thinking that what does it give me, apart from cheap cost, if I compare it to like something like Azure website, for example. It's not like a Lambda, but it gives me almost the same thing that you were showing, and it looks like more, I'm doing event-based architecture, very much tied to proprietary Amazon ecosystem now.
Yeah, so like I said, I know nothing about, I haven't even looked at Azure yet, Azure functions yet.
I'm just saying Azure website, for example. That's serverless. I don't have to care about server, but I can put a normal application without getting into like micro lambdas or something like that. I still don't have to care about servers.
Sure.
Does Amazon have a similar?
Oh, they've got CloudFront and S3 where you can host your websites. But to build entire web application with sort of backends, that sort of work, that's where it's powerful.
Because when you show an example like this, is quite trivial, a small thing from database fits in your head and all. But like, say I have this fancy sorting algorithm that I want to reuse in 20 different lambdas.
Oh, you can do your libraries. You can. I've just shown you the easy one. You can put that in a library and include that in all of your lambdas that you want to use it in.
So you can like build like packages and.
Yep. You can do that in AWS. So I just showed you the sort of easy way out. You can upload a zip file. You can upload a zip file with all of the stuff in there. So you can build if it's Java, you can use your jars. In Node.js, you can use your npm packages, and you can even upload binaries. It's just it's running in a Linux container, so you can sort of upload your binaries in there and sort of call them from like a node, for example. So yeah, you can use whatever you want to run. Yeah. Sort of you're trying to answer a question.
In the immutable services world, do we have anything like version controls, so like version control systems for code? So because you mentioned that the codes will never change.
Yes. So yes and yes and no. Again, the tooling around this is very, very basic still. You can have different versions of your lambdas, and you can have them running at the same time. Yeah, so you can have different versions running at the same time, subscribed to the same or different events. So you can have multiple versions. What I find is that that isn't so. It doesn't happen very often that you have different versions of the same code. A lot of the time, if you make a change, it's most often because your contract changes. And if your outside contract changes, you basically have a new service.
You don't have the concept of refactoring for functions?
No. Right. Like I said, the tooling right now, there's very little tooling to help you sort of manage different versions in sort of running at the same time. AWS supports it, Absolutely no problem. You can have different versions of the same Lambda in production running at the same time, and you can sort of point to different versions, specific versions of your Lambdas, but there's very little tooling to sort of help you manage that just yet. Like, ask me again in like 3 or 4 months, basically.
Do you know of any websites or companies, examples who are using?
Most of the examples that we see sort of right now are sort of relatively small. I'm sort of one company I'm sort of talking to. They use it for their big data ingress, right? So they chuck big things on an S3 bucket, and then they use lambdas and sort of process that and sort of make sure it gets into their Hadoop cluster. If you talk to Sam Crone and Peter, can't remember his last name, something with an S, they're running a Cloud Guru. They basically have their entire application sort of running in this type of environments. Car sales downstairs, upstairs in the pavilion, doing the same thing. Right? They're using it in sort of their analytics platform. So they're not building entire applications just yet, but people are starting to use it for sort of parts of their stacks. So there's no massive adoption yet, but we're definitely seeing the trends to build bigger and bigger things out of it. But yeah, it's definitely used in sort of massive production loads with sort of thousands or millions and tens of millions of requests a second, or requests per month, right? Not millions a second. That'd be cool.
How do you handle failure?
Yes, that depends. So how do you handle? The question was how do you handle failure, right?
When lambda goes out.
So theoretically, you could. There are sort of two things. Like, you can sort of fall back either on other regions, or you could fall back to sort of EC2 instance if you really wanted to. But yeah, it would only be a problem if sort of lambda goes down in like an entire region, right? Because they take care of the provisioning, like an availability zone, like sort of happened a couple months ago in Sydney. You shouldn't notice any of that sort of going down.
So with that, like, with how easy you construct lambda, I can sort of think like, so for example, you could have like 1,000 lambdas in real production service kind of thing.
Yep.
And some of those lambdas can actually chain together, like in that.
Yep.
Things that in the diagram you saw, and this actually relates with the failure again. Like, if one of those chains breaks down or something like that, how is there like some sort of monitoring or some way? What things that or strategy that you can actually implement?
So and again, that sort of goes back to your monitoring, right? It's the for example, this one, right? If this breaks, if we sort of get from that, if this post isn't put on the SNS queue, none of this other stuff happens. Right? And that's why it's so important to sort of start monitoring these things. It's important to sort of monitoring. Do we get the expected amount of SNS notifications? Is the lambda still intact? Did someone sort of break this particular link here? There's no tooling out of the box that does that. You can all of this stuff goes into CloudWatch, so you can sort of do a lot of that metrics based, set alarms in CloudWatch, as you would do with any normal component. So you can do some of it, but again, the tooling around this to sort of do that supporting and scaling are in their infancy right now. Yep.
Yep. I have two questions. The first one relates to the latency, even with that simple three-layer simple applications. The throughput in your demonstration
Yep.
was 131 milliseconds, which is very high compared to the native app. We can easily achieve less than a half.
Yep.
Secondly, why do we need to specify the RAM? Even we can specify the throughput.
Good question. So the first one talks about sort of latency and how that works. So there's a couple of sort of interesting things that are happening. The 130 milliseconds was on our cheapest versions of Lambda, right? So your CPU and your memory are linked. I put it on the lowest memory setting. If you put it on a higher memory setting, you get more CPU and your throughput will decrease dramatically. So you can go to sort of half that quite easily. You can probably go to a quarter if you really want to. So that, a lot of that is to do with specifying your sessions. The other sort of thing we have is what we call cold starts. If a new Lambda is started, you have sort of hundreds of milliseconds, often, so sometimes even sort of a second delay in sort of that starting that up. But the most important thing to realize is that we're talking about this point over here, right? Everything after this is asynchronous.
No, I mean the front one.
But so this is the front one, yeah. So this will be, you can get that down to tens of milliseconds quite easily by just playing with the memory settings on this one.
You did the test before that, so it's not cold start anymore. And then you came out
Yep.
and you query the API, still the latency is 131 milliseconds. So
But that had everything to do with the settings of the Lambda. It was the cheapest version. Let me see what we can get it up to. Where am I? Oh, they're here, of course. So let's do a mirror. Here again, Lambda. Configuration. Where's my memory? Advanced sessions.
yeah, why do we need to specify memory? Because we can.
So that's what I'm saying. So the reason we're specifying memory is because memory and CPU are linked one-on-one. So the more memory you give it, the more CPU it gets at the same time. So if we, where's my, so save and do the test. If we sort of run another test here, we're talking about 33 milliseconds, and then from API gateway, to do this, it's still in there. And this is sort of where we get that. So it varies quite a bit, and it also happens sort of on so you get the high tens is your latency.
Stick quite high, huh?
Sure. It's probably good enough. Considering all the other things you can be doing. So that's sort of what it's going, right? It's yeah, like tens of milliseconds. Probably good enough for most of the use cases that we're working on. There was someone else. Yep.
Yeah, actually, just want to ask a question about design and documentation. Because in the design phase, you probably create all these lambdas and different lambdas doing different things. So you probably ended up having like 100 lambdas running around. How do you maintain this? Say somebody else comes on board and then you have to, go one by one, or is there a button that you can press and everything, all the lambdas display in a nice way so it's easy to understand?
Gee, that sounds like a great idea for someone to build a tool around. No, like I said, tooling around it absolute sucks. You have this, for now, you have this interface. And this gets larger and larger. And it's sorted alphabetically.
Right, so you don't know if this lambda talks to this other lambda.
Nope. There's nothing that gives you sort of this types of, because this is what you want, right? And you want to sort of collapse this and sort of open that up, and no, tooling around it is still very, very much in its infancy. Yep. Right. last one? Or are we going to go and grab a drink?
You mentioned obviously no unit tests, but what is your testing strategy? Do you just end up with a bunch of integration tests and performance tests?
I think it depends a bit on the situations that we're in, the changes that you're making. But things like integration tests on that much larger scale start making a lot more sense, right? So that's you don't test the units anymore. How do we test the bigger and bigger components that we're building out up from these smaller components? So you would a lot of it would be testing from the UI, for example, just go through. But a lot of the stuff I do is sort of manual. Just go do a CURL on that HTTP. Do I get back the results that I expect? Sort of go into the UI. Does it still sort of work? And because we make such localized changes, it's actually fairly easy to see sort of what the consequences are. So it's easy to see what you would expect to happen, and sort of verify that it did indeed happen. And the chances of it breaking something somewhere else is relatively slim. So all of the testing I would do are sort of on that much sort of bigger level. No, I think this is starting to sort of the ultimate sort of DevOps, right? Where there's no what's ops and what's dev, right? It's the same thing. We're doing the same thing. It's sort of managing and monitoring all of this stuff is going to be we're stalking, and that's why sort of serverless is such a sort of terrible name, because it doesn't imply that we're not doing ops anymore, right? There's still tons and tons of ops. I can't remember who it said, but one of the amazing quotes is you can outsource your sort of as much of your operations as you can. The one thing you can't outsource is caring, right? Amazon doesn't care about your application. You have to care about your application. You can't outsource that to anyone else. And that's ops, right? Amazon can give you the amount of messages that's going through that SNS topic. But what's good and what's bad, we're talking ops, right? We're talking monitoring. But no, I think this is sort of the holy grail for DevOps, where that line is getting blurrier and blurrier. Sort of what is dev, what is ops? It's all the same thing. Yeah? All right, thank you very much. Appreciate it. And see you around.